Assalamualaikum and good morning for everyone. And my name is HAIKAL, my YUSRI, Matrix F35A8041 from SFH, which Animal Husbandry Technology. And today I will be leader from the presentation by Group 7. I will start the introduction and explain that's graph. I prepare myself before passing a group member for their parts. Okay. The summary of the science problem. The bioscience problem is the project growth performance broiler chicken in Malaysia poultry industry. In commercial farming, feed the cost every expensive and can reach around 70% of the total production cost. Besides that, Malaysia has a hot, humid climate which cause heat stress broiler chicken. When a chicken experience heat stress, they are eat less, grow slower in production as scientific decrease. Um, okay, please explain the meaning of the points, the mathematical model. Um, First graph show two lines. The green lines represent the broiler weight growth, while the purple dotted line represent that average daily gain of the growth rate. The mathematical model is F as equal W max E. In this equation, S mean the age of the broiler in days, and F open bracket as close bracket means a total weight the broiler. W max is the measure maximum weight. K is growth rate constant. Ti is inflection point, which the peak growth age. Next will be okay. Next, we use the first derivative to calculate the growth velocity of ADG. F as equation F as KE negative K open bracket as negative TI close bracket. This derivative show how to fast a chicken grow every day. For example, when the click 20 day 21 day 21 for example this mean a chicken growing actively during this phase. And recommendation or improve the HTML web page. For recommendation for improve HTML we page is to add more interactive feature is simple implementation for use. For example, we can add animation for the graph, dark mode interface, mobile friendly optimization, and simple notes for users who are not familiar with calculus. This will make a web page for attractive, easier to understand, for use friendly. That's all my parts. Now I would like to pass the presentation to my group member for the next slide. Thank you.
Good afternoon, everyone. My name is Amni Mirza Binti Mazlan, and my number metric is F25B1584. Today, I will present our project title is Modeling Oil Palm Canopy Growth Rate via Derivative. In Malaysia, agrotech maximizes early vegetative growth of oil palm. It's a vital of minimizing the emission pace before commercial harvesting. This interactive simulation model the canopy project area (CPA) of high-yield Tenera oil palm cloned during its first 60-month post-field planting using a biological logistic growth function. In this project, mathematical model and derivative calculation to study the growth pattern of palm oil. The graph on web page have a two line. The blue line it shows the total canopy area, and the orange line shows the growth rate. At a 30-month, canopy area become 17.5 square meter, and the growth rate is 1.05 square meter per month. The calculation show F30 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 70.5 meter and F30 1.05 per month. This means the oil palm canopy is increasing by 1.05 square meter every month during this stage. This is the fast growth stage of the palm oil. Studying the bioscience problem is important because the oil palm is one of the main agriculture crop in Malaysia. By using a simulation and directive, researchers and farmers can understand the growth of oil palm more clearly. It can help improve plantation management, reduce fertilizer waste, and increase the production. Next, we click a paragraph. We can see information for each month. The blue point show the canopy size and the orange show the growth rate. For example, we click at a 30 month. The system display the canopy area derivative value automatically. This help user understand how the oil palm grow over time. Lastly, one of a way improve this HTML web page is by editing more animation, picture, or interactive button. This can make the web page more attractive and easier to user to understand. That's all from me. Thank you. Next, I pass to my group mate.
Assalamualaikum and good day everyone. My name is Muhammad AMMAR bin Mazlan. My metric number is F25A1437. So this project name Ayam Kampung Asli Growth Kinetics. So this applying calculus derivative to poultry science and livestock management. So in this project, I apply calculus derivative in analyzing the growth pattern of Malaysian indigenous village chicken, or also known as Ayam Kampung Asli. So the purpose of this project is to model chicken growth scientifically and determine the rate of growth to a 24-week production cycle of the chicken. So the bioscience information is this simulator models the baseline growth curve of Ayam Kampung Asli chicken in Malaysia. So the data coefficient were calibrated using local Malaysian agriculture references such as MOHD production guides and Malaysian Journal of Animal Science Studies. So the chicken grows from approximately 30 grams after hatching until reaching mature status around 1.9 kilogram. So this map of project is highly relevant to poultry science, livestock management, and agro-based industries in Malaysia. So now look at the equation. So first, on the left, we have the Gompers growth function. So this equation is to models the cumulative biomass weight of the chicken over time. So at the graph, the X present the age of chicken in weeks, while the Fx represent the total biomass weight in grams. So this Gompers model is widely used in biological science because it accurately represents natural growth behavior. So on the right equation is the derivative equation. So this derivative represents how fast the chicken growing at the specific week. So this allows farmers or researchers to identify the most efficient feeding and development period along the cycle. So now look at the graph. So at the early stage, the growth rate increased. As you can see, the green one, the red one. So it increased rapidly because the chicken are still developing muscles and skeletal tissue. So next, after the peak around week 6 to week 8, it indicates the faster growth periods. After that, the derivative gradually decreased because the chicken began approaching their mature body weight. So next, the calculus and biological interpretation. So as we can see at the week 7 or 6, the total biomass is around 372 grams. So what the derivative value is 133 from 0.5 gram. So these highly positive derivates that the chickens are experiences explosion biological development. So at this phase, nutritional optimization such as amino acid and crude protein intakes become extremely important to maximize the health and the growth of the chicken. So lastly, I think for improving the HTML, it is better to have the semantic elements such as the header, the main, and the footer. So this website would be more organized and easier for people to understand as will be published publicly. So that's all for me.
Good afternoon, everyone. My name is NAZIFA anak perempuan Hai. My metric number is F25A1850. Today, I would like to present my project, Biocalicus Application Category. This is focusing on the local Kedah to Kelantan breeds. The main problem farmers face is determining the mass profitable time to harvest our seal layer cattle. So, if sold too early, the meat yield is low. If kept too long, feeds cost waste away because the cattle white particulars. To solve this, I developed this web similar calicus to find the perfect economy balance. So, I adapted data from MOHD to construct this logistic growth model. F of X cattle weight calculates the axillary weight of the cattle based on AZMAN, and then F prime of X growth rates. This is first detective, which is tell us the axillary velocity of white gate per month. So you guys can see this graph. We can easily identify three phases. The first one is identically phase. 0 to 5 months. Growth is relatively so slow. And secondly is peak phase. Around 10 months. F prime of X value is high. This is the inflection point where the cattle grow the fast. And the last one, peculiar space. Around 18 months, the curve flat and F prime of X approach 0. The cattle have ritual stop growing. So the conclusion of the similar help farmers pinpoint their optimal sublater age, allowing them to cut down unnecessary feed costs and maximize the net profit. So that's all from me. Thank you.